Okay, so welcome to part 6 of the standard ASHEE tutorial. So in the last video, we actually finished setting up and ran our volcanic plume case. And so I think on my desktop computer with about 4 processors we were using, it took me about 4 to 5 hours. I wasn't timing it exactly, but it takes a while. It's for 1 hour of volcanic eruption, about 4 or 5 hours of real time. And so, well, we can come to our terminal here and type, we can look at the last 500 lines of our log file here. And you can see where we got to time 3,600, so then we got to time 1 hour. And we got a nice message here, finalizing parallel run. So everything seemed to work smoothly. Another really interesting and useful piece of information is the maximum courant number during the whole simulation was just over 0.2. So if you remember, we set our maximum to be 0.2, so this is pretty good. So this tells us that nothing diverged and everything, the simulation was stable and everything was happy in the simulation. So that's great. So now, of course, we would like to visualize our results, right? We'd like to analyze and visualize our results. So at the moment, we can't do that directly because if we come back to our folder here, that folder with our case, we have these 1, 2, 3, 4 folders for the different processes. So we ran the simulation on 4 processes. And so the information about 4 different parts of the domain is mixed up in each of these 4 folders. So before we can visualize, we have to reconstruct the whole entire simulation from these 4 folders into a single folder. Okay, and the way we do that is a command called reconstruct par. So this will basically just take those 4 folders with all the information about the simulation in and reconstruct these into a single folder so that we can visualize and analyze our results. This can take quite some time to run because it has to go through every single time step that we've saved. And so in my case, I saved an hour's worth of simulation every 36 seconds. So I've got 100 sets of results that this command has to go through. So this is going to take probably an hour or even more. So I'm going to pause this video and let this go. Okay, so in fact, it only took about 20 minutes to reconstruct those 100 files. So now we can move on to actually visualizing our results. So let me first just clear the screen here. Clear. And now we can start visualizing our results. So what I'd like you to type is, we have to create a file actually, an OpenFOAM file for our results viewer to interpret. So what I'd like you to type is touch mycase.openfoam. So touch just creates a file. MyCase, well, this is just the name of the file. You can call that whatever you like, really. But the important part is .openfoam. O in open is a capital, and foam is all capitals. Okay, so that should quite simply create a file. And now, what you would to visualize our file is type paraview. So that's all lowercase, and then this file we just created, mycase.openfoam. So if I type paraview mycase.openfoam and press enter, then it should load paraview for us. Okay, so at the moment we can't see anything. In the next video, well, we'll go through visualizing, but I can show you at least that we are looking at our domain. So well, perhaps we should look at velocity, magnitude, and we'll take a slice through the middle. If I rotate that, at the moment we're at time 0, so we can't really see anything particularly great. But if I press play, you'll see our eruption beginning. So congratulations, we've set up our eruption. So the first thing I can see from this video is that perhaps my domain is too short, because I can see that my eruption is getting quite close to the top here, and that's not really ideal. Okay, but in the next video we'll process this data anyway and see what we can come up with.